Hello and welcome to this video tutorial on how to use the Data Lifecycle Manager tool, also called the DLM tool. My name is Axel Meyer and I'm with the P&I team developing the Data Warehousing Foundation tools, which includes the Data Distribution Optimizer and the Data Lifecycle Manager. I'm going to show you how to explore a dataset, create a storage destination, create, adjust, execute, and check the logs of a lifecycle profile by using the DLM tool. In addition to that, I'll also demo to query the generated DLM objects, which can be used to interface with your native HANA application. Let's start with a quick DLM overview. This is the DLM home screen. The Data Lifecycle Manager is developed using the modern UI5 libraries, so we're capable to run in browsers like the Internet Explorer, Chrome, or Firefox. On the home screen, you see the different tabs you can mouse over to jump to the certain topics, which is the Explore, the Manage Storage Destination, Manage Lifecycle Profiles, and the Log section. In addition to that, we'll also provide you additional KPIs in terms of number of runs within the last 7 days in the system, which is in this case 75, and also the status of the last 3 runs, where in this case we have 2 runs completed and 1 is still in process to be executed. Next to this information, we'll also give you information on the node utilization forecast, which should give you a hint and provide additional information on the past utilization of the system, where we separate between the different nodes using nice color coding, and we'll do some estimation on your current date and the past activities on the system, and do some prediction on how the system memory usage would evolve if no activity in terms of lifecycle management would be added to the system. This should be an indicator for you to find out on how the different nodes will be utilized in the future. Let's move on to the Manage Storage Destination section. And hit the button. You can filter on your existing storage destinations. By hitting the plus sign, you're capable to create a new storage destination. You have to provide a name to the storage destination, and then within the options of potential storage destination, you have to decide on your certain storage destination, which could be either SAP IQ via SDA, dynamic tiering, or a delete bin destination for data deletion by using the DLM tool. In today's video, we're going to choose the dynamic tiering option. In the lower part of the parameter section, you're capable to override the predefined database schema where the certain objects will be created. For this session, we're going to leave the predefined parameter section unchanged. Hit the Save button, hit the Activate button so that the storage destination gets activated. Once it gets activated, you can check the connection where the system will talk to the dynamic tiering host. Based on the green color coding, it's an indicator that DLM is capable to connect to the dynamic tiering service. Let's start to create a lifecycle profile. I'm going to mouse over the section and enter the dialog to create the lifecycle profiles. There's a filter section on the top where you can specify a certain set of characteristics to query on some existing profiles. In this case, no profile with this prefix exists. So I'm going to hit the plus button to create a new lifecycle profile. We have to specify a name, and within the source persistency section, we're going to select the table we explored early on. Let's specify the schema. With the auto completion, you get a nice selection option. Specify the table name. On the right side, you see a trigger type. This is the way on how you can execute your lifecycle profile later on. You have the option of manual and scheduled. Manual is just a direct execution, where scheduled provides you the option for some unattended and planned execution of the lifecycle profile. The execution of the lifecycle profile will later on transfer and displace the data between the two data stores. In the lower part section, we're providing additional information to specify the lifecycle profile. There's information available on the destination attributes, on the destination persistency, on the rule editor, and the generated objects. Within the destination attribute section, we're providing information on the storage destination, like the destination we created early on. Connected to the name of the storage destination, the certain persistency type is being displayed. By lifecycle profile, you can specify the relocation direction, like the direction the data is being transferred. You have three different options: hot to cold, cold to hotter, and bidirectional. Let's stick with hot to cold for this moment. Next option would be the package size. As we're moving large chunk of data between two stores, we're selecting and inserting records on a package size and within a package. So it's not a record by record transfer. We're selecting the data set to a package and then inserting the full package size of records to the target destination. A default value of 1 million is specified. Due to the fact that we're talking about two different data stores, a clash strategy also needs to be specified once a primary key violation would be identified. There are two clash strategies available. One is stop execution, which will roll back the full lifecycle profile execution, or the override, where the data in the target destination will be overwritten. For the moment, we'll stick to stop execution. The same option can be selected for the cold to hot data movement strategy, where we also stick to stop execution. Next section would be the rule editor. Once you click on the rule editor, a dialog comes up where you can select different elements to be leveraged within the rule to move the data. Within the column section, you can specify the certain fields where we'd like to focus on cal month. I'm going to specify the filter for cal months, so it's SQL-like within the where clause. And in addition to that, we also want to select for some month only, and here we want to focus on month number 3. Once you hit the validate syntax button, it checks on the validation of the correct syntax. In addition to that one, it will also give you the affected records dialog. Let's move on to specify the rule within the lifecycle profile to identify the records in the source and transfer them later on to the data target destination. On the lower parts, you see the different elements of the source persistency table, where in this case, we'd like to focus on the calendar year, give it a filter. In addition to that one, we're also interested to move a smaller portion of data to the storage destination. Let's give it the option to validate the syntax. Validation went well. On the right side, you also get the information on the specified relocation direction, hot to cold, and the affected records by the given selection. You can go on and change the rule editor setting, hit again the validation syntax button, and you immediately see the amount of affected records. Let's stick to the specification we used early on. I'm going to save the rule. In the upper part, you see that the data distribution overview has not been adjusted as we haven't executed the lifecycle profile. The source, the number of records, 6 unchanged, and in the storage destination, the number of records is 0. Next step would be to activate the lifecycle profile. Once the lifecycle profile gets activated, additional information will be provided. In the destination persistency, we're providing the information on the DLM generated persistence object to be used to keep the displaced data. An object is being created in the schema listed here, and the name is also listed here. As its type of dynamic tiering, this table type is classified as an external table. On the lower part, DLM also creates additional union views to provide a native HANA application the option to display and access the full data set. We have 2 union views in there. One is the pruning node view. The pruning node view will give you the option to query on the full data set, but it includes some dynamic pruning options where we're analyzing the SQL where clause, which will query the pruning node, and based on the specified options in the rule editor, we dynamically prune the access to the only relevant data store. Next to it, we're also generating a union view as a fallback strategy. The union view is being used and generated the same way you would specify a union in SQL. The union view will be always there, as for some storage destinations, we don't have the option yet to generate a pruning node view. Both views can be independent to each other, integrated into HANA applications, or being added to virtual data models, like integrated into a HANA calculation view. Within the generated object section, a relocation procedure is being created. We extracted the information specified in the rule editor and integrate this information from the rule editor into a HANA store procedure. The relocation procedure is executed once the lifecycle profile will be put in run mode. Let's move down to the additional buttons. The Simulate button will give you the option to simulate the relocation. We have two options: the Data Relocation Preview, which gives you the full information on your destination, the name of your data flow, the relocation direction, cold to hot, and as we only specified hot to cold, we're displaying the relevant data records from the source persistency. Next to that, we're also providing a data relocation count within simulation mode. Within this option, we do not display the content of the records. We're just displaying the number of records being displaced within the certain direction. Before we move to the run mode, we have two more options, which is the export and the import. Within the export option, we give you the option to export your full configuration to have a lifecycle management established also for DLM. In a later version, we're fully integrated into the HANA Application Lifecycle Manager. For this moment, we're providing an option to export and within the target system to import the full configuration of your lifecycle profile. Let's move on with the run option. Within the run option, we have two options in general, where once you selected the scheduled option trigger type, we're also offering the scheduled option to really execute the lifecycle profile. If you stick to manual, we're only providing the trigger manual option. Within the schedule relocation run dialog, you can specify on the date time you want to execute the lifecycle profile, if a certain recurrency should be specified. It will also give you the option to stop the execution and roll back the full activity on the execution of the lifecycle profile, in the sense that your time window is limited to perform the relocation runs. I do not specify anything on top, just provide the password, hit confirm, and the information pops up that the relocation run has been successfully started, and we should refer to the log screen. It takes a moment for DLM to initiate the execution of the lifecycle profile. Let's move on to check the logs of the lifecycle profile. An automatic filter will be applied and a certain ID is being specified, which is an indicator and an ID for the relocation run. Additional information like this lifecycle profile ID, the user who executes the lifecycle profile, the run status, it's completed already, the trigger type, the start time, the end time, and also the estimated data relocation count. If you click on the ID, further information is being displayed. The relocation run completed successfully. Let's go back to the lifecycle profile section. As we remember, before we executed the lifecycle profile, the initial state on the data distribution overview is being displayed. Once you execute it and the relocation run successfully completed, and you hit the lifecycle profile again, the data distribution overview got updated. Within the source, the number of records gets reduced, as we moved 326,000 records to the dynamic tiering storage destination. In case you want to further adjust the existing lifecycle profile without interfering with the generated objects, which can be integrated to native HANA applications, you can simply switch to the rule editor, switch to edit mode, and probably change the existing selection from 2010 to 2011. And as we displace data from 2010 month 3 already to dynamic tiering, and we're now specifying that only data for 2011 should be displaced from hot to cold, we also need to switch back on the relocation direction from hot to cold to bidirectional, as the system has to bring back the data from the previous rule editor setting, like the 2010 March data, into hot store, and it's going to displace data only for calendar year 2011 from hot to cold. If we validate the syntax, it brings up the information on there are about 1.3 million records to be displaced based on the updated selection criteria. But we also need to bring back the 326,000 records which have been displaced to dynamic tiering already, and that's going to move from cold to hot. I'm going to save the change. I'm going to activate the profile. And again, within the activation step, the generated objects within the destination persistency will stay unchanged. So you can adopt and adjust your rule editor setting, and your integration layer objects, like the generated union views as an example, will stay unchanged to the upper application interface. Once we hit the simulate button again, it should give us the same information we saw early on. The information displaced already will be transferred back into HANA hot store information, and the data relevant on the existing rule editor setting will be transferred from hot to cold. Let's execute the updated lifecycle profile. The relocation run successfully started, and we need to wait a moment until the information becomes visible in the log section. Let's move on and check the logs for the current execution of the lifecycle profile. A new ID has been created, same ID, lifecycle profile number, same user. The status is still in progress. Trigger type scheduled, the start time, the estimated data relocation count. We'll get all the details once we go into the details section of this log. Let's get started. The estimated relocation record count is being estimated for the cold to hot destination direction. The number of records moved from destination to source. This is the hot to cold replacement displacement. And this is the current status. Relocation data from destination completed. Relocation to hot, from hot to warm destination is in progress. The processing package of the relocation 1 is being processed right now. The information got updated 1 million records got transferred from source to destination. You can read yourself. A new package has been created as the package limitation has been specified to 1 million. So package 2 gets created and the remaining records gets transferred from source to destination. The relocation run completed successfully. Let's refresh and we're good. We now switch back to the lifecycle profile section. You would remember this is still the status from the previous run before we executed the lifecycle profile the second time. Once we refresh, we select the DLM profile. The information on the data distribution overview gets updated as we now displace 1.3 million records from HANA Hot Store into the dynamic tiering warm store location. Next to the already demonstrated rule editor settings, we also give you the option on some date functions. To show you the details, I'm going to create a new lifecycle profile. Give it a name. Specify the profile. Give it a table name. Trigger type scheduled. Relocation direction and everything else will stay unchanged. Within the rule editor section, I'm going to use a column called order date. And we're interested to displace data on a recurrent procedure where the rule editor should specify and use a date function, which is the add days option. And within the add days, you can specify the current UTC timestamp, and we should specify the number of days back to be displaced. In this case, we're interested to displace about 6 years of data, which is about 84 months, and in total somehow close to 2,555 days. Having said that, if we check the syntax, the system will go back and identify on how many records are affected by this selection. Where this rule is type of dynamic, as if you schedule the execution of the lifecycle profile on a frequent manner, the rule will automatically specify your current UTC timestamp and always calculate 7 years back, so that you always get a stable window of data set in your hotstore table, and dependent on the frequency of the execution of the lifecycle profile, the rule will transfer on a daily execution only one day of data set from the hot store to the dynamic tiering in this case. So that's a dynamic way to specify the rule editor using the date functions we're providing with the rule editor. Let's save it. Activate the profile. Simulate the execution. Finally, execute the lifecycle profile. The relocation run successfully started, and we need to wait a certain moments before the relocation run finally kicks off. Let's check the logs. Profile get automatically selected. We have got a new ID. The status run is already completed. Let's check the details. So the relocation run got started. It estimated the number of records to be displaced, relocation direction, and so on. And finally, the relocation run completed successfully. Switch back to the lifecycle profile, update the data distribution overview. You get a nice overview on the number of records being transferred to the dynamic tiering location. If we switch back now to the home screen, we'll see that the number of runs in the system got updated, and also the recent status is being displayed. This is the end of this video. I'd like to thank you for taking the time to watch this video. Goodbye. In this section, I'd like to demonstrate on how to access the generated lifecycle profile objects by standard SQL. Let's switch to the already created lifecycle profiles. Query on, check the first lifecycle profile and check on the rule editor settings. Last setting was to displace data relevant for Cal year 2011. So this is the data set being active in the dynamic tiering data, and the remaining data set still sits in the source persistency. If you switch to destination persistency, you'll find the persistent objects like the dynamic tiering table specified in this schema. This is the table name, and also the pruning node to access the full data set. Let's switch to HANA Studio, where I'm connected to the DD4 database tenant relevant for our demo. Let's start to count the number of records in our source table. And execute. The number of remaining records in the source table is close to 7 million. And also select the number of records available and displaced to the dynamic tiering table. As listed before, the table is accessible in the schema, and the table name has been derived from the Dlm profile. Let's run it. The number of records let's specify the number of records displaced and available in the dynamic tiering table. The dynamic tiering table has been created in the schema. The table is available within the table section. This is the number of records being displaced, so the total need to be specified right now. Let's use the generated pruning node to query the complete data set. The generated pruning node is available within the same schema within the column view section. And as we want to find out, based on the latest rule editor setting, how many records are available in dynamic tiering by querying the pruning node, we can apply the filter according to the rule editor setting. Latest setting was calendar year equals 2011. Let's query the pruning node. And the complete result set is being displayed. As we listed before, this is the exact same number we queried before on the dynamic tiering table. You can also apply any other type of filter, like if you want to query for calendar year 2010 and cal2 equals 3, which has been our initial setting for the data movement rule on the same lifecycle profile. You can take it and run it. Query returns exact the same amount of records we displaced initially when we set up the lifecycle profile. This record count is determined right now based out of the table in the hotstore table. As with the latest setting on the lifecycle profile, we only displace data relevant for calendar year 2011. With this selection, we're also querying the data within the hotstore table, and the dynamic pruning node logic will make sure that it analyzes the where class and only selects the data out of the hotstore table. The pruning node is specified to act as the integration or interface layer to your HANA application. As we provide the complete access to the full data set, you can apply any filter you like, and the pruning node logic will make sure to optimize the access and prune the access to the only relevant data stores. If you want to further on create some virtual data models, you can simply use the generated pruning node and integrate the pruning node into a calculation view. To do so, scroll down to the content section within the user I'm working on right now. We have a package created. I'm going to create a new calculation view. Give it a name. The calc view editor starts up. Let's move up to the catalog section to identify the pruning node view. Mouse it over, and the number of available fields is being displayed. Let's select the objects as a subset relevant for our query. Apply the semantics. Check and activate. The calc view got successfully activated. If you now switch back to the query interface, we'd like to access the calculation view with the included DLM pruning node via an SQL statement. The generated and activated calc view is available within the SysBig schema. Let's mouse copy it over and apply the filter relevant for the current specification of the lifecycle profile. Let's execute the calculation view. And the result set is being displayed, which is the same number of records available in the dynamic tiering table. The same amount of records have been also accessed before when we were working on the current selection of the dynamic tiering table. So you can query any type of SQL on the generated and activated column view of the calculation view. Again, you can not only query on the generated pruning node view to access the full data set by given any type of where clause, which can already act as the integration and interface to your HANA application. You can also integrate the generated pruning node into a virtual data model, in this case a calculation view, which can be also further stacked with additional calculation views on top. The included pruning node will automatically optimize the access to the relevant data stores, so there's no additional effort required to optimize the access to the right data store, if that's going to be a HANA table, a dynamic tiering in our example, or some external sub-IQ database, or with a later HANA SPS 10 version, the access to Hadoop via Spark interface. This concludes the section on how to access the DLM generated object using SQL, and it should also highlight the option to integrate the DLM generated objects into your HANA application. We still get the flexibility to adjust the data movement rules within your data lifecycle manager section, but the interfaces to the outside to be integrated into HANA applications will stay stable, so there's no change to the generated HANA views, in this case the pruning node view. And you get the option to keep your HANA application stable as DLM manages the underlying movement of the data without changes to the interface views. Thank you for watching this video. If we switch back now to the home screen, we'll see that the number of runs in the system got updated, and also the recent status is being displayed. This is the end of this video. I'd like to thank you for taking the time to watch this video. Goodbye.